In this video, we are delighted to introduce CarlaOcc, an instance-centric panoptic occupancy prediction benchmark for autonomous driving. In camera-centric perception systems, panoptic occupancy prediction task aims to jointly infer voxel-wise semantics and instance identities within a unified 3D scene representation. However, existing benchmarks typically provide incomplete and low-resolution geometries without instance annotations, limiting models' capabilities for precise scene reconstruction and holistic 3D understanding. To address these challenges, this paper presents an instance-centric benchmark for the 3D panoptic occupancy prediction task. Specifically, we introduce AdMesh, the first unified 3D mesh library tailored for autonomous driving, which integrates over 15,000 high-quality 3D models with rich semantic annotations. Building upon AdMesh, we introduce CarlaOcc, a large-scale, physically consistent panoptic occupancy dataset featuring 100,000 annotated frames and a fine-grained voxel resolution up to 0.05 meter. Here is the overview of the proposed AdMesh library and the CarlaOcc generation pipeline. The AdMesh library is constructed by extracting and reorganizing diverse 3D assets from multiple sources, including MeshFleet, ShapeNet, BuildingNet, and CarlaUE5. Subsequently, these static meshes and scene layout are further used to reconstruct dynamic scenes with both static structures and temporally aligned non-rigid motions. Finally, the resulting unified scene meshes are used to rectify sensor artifacts and further processed with a topology-aware mesh permutation strategy to produce non-overlapping panoptic occupancy labels. We compare the quality of occupancy ground truth with LiDAR-based methods such as OCC3D SSC Bench and CarlaSc. These datasets lack instance-level annotations and are limited by sampling density and sensor noise, inevitably leading to broken surfaces and ambiguous object boundaries. In contrast, our mesh-based pipeline avoids these limitations to deliver geometrically complete reconstructions alongside accurate instance annotations. Here we show the exported 3D assets with semantic labels and the canonical walking cycle for handling non-rigid movements of pedestrians. By assembling these assets, we achieve city-level panoptic mesh reconstruction that highly consistent with the RGB renderings. Compared with point cloud-based occupancy reconstruction methods, our mesh-based occupancy generation pipeline supports arbitrary voxel resolutions as fine as 0.05 meters, while exhibiting less cross-frame jittering and better physical consistency. This multi-resolution capability empowers researchers to flexibly adapt their models to different computational budgets and application scenarios. As shown in the video, to enable holistic scene perception, our pipeline renders a comprehensive set of perfectly aligned data modalities. Specifically, each frame includes high-fidelity RGB images with rich annotations, metric depth maps, surface normals, semantic segmentation maps, semantic LiDAR, and panoptic occupancy ground truth. Due to Carla simulator rendering pipeline limitations, transparent objects often suffer from depth errors and semantic label loss. To address this, we utilize raycasting to effectively recover the correct depth and semantic information. This successfully restores these challenging areas, particularly transparent objects like car windows, streetlights, and bus stops, ensuring high-fidelity ground truth for the entire scene. Thank you for listening.